Determine the domain and range of the following relation. Example 1b. The set -5, 1, 4, 1, 7, 1, 5, 1, -1, 1. All right, let's start by finding the domain of this relation. The domain, recall, is your set of inputs, your set of x values, the x coordinates of each ordered pair. The domain for this relation consists of -5, 4, 7, 5, and -1. Putting them in order, that means the domain consists of the set -5, -1, 4, 5, and 7. Let's do the range. The range, recall, is your set of outputs, your y values, the second coordinate of each ordered pair. And notice in this relation, the range simply is the single number 1. It occurs over and over and over again. So the range consists of one value, and that being 1. Now, is this relation a function? In order for it to be a function, each element in the domain must map to one element in the range. How do you determine that? Well, look and see if your x values are repeated. Notice here -5 maps to one thing, and it doesn't map anywhere else. 4 goes to one element. 7 goes to one element. 5 goes to one element. -1 goes to one element. The x values do not repeat. They go to a single y value. Now, it just so happens they all go to the same y value, but that's okay, because each element of the domain only pairs to one element in the range. Therefore, this relation is a function. It is both a relation and a function. Again, why? It's because each element in the domain only maps to one element in the range. Because this is such a small example, let me go over here and draw you a map for it. If I was to look at this as a map, I would have -5, 4, 7, 5, and -1 being elements in my domain, and my range consisting of the value 1. And notice each of these elements here maps to this value 1, but each of these elements only goes to 1. It doesn't go more than one place. That means this relation is a function, and this is a more visual representation of that fact. Let's take a look at example 1c. Our next example is an example of a relation expressed as a map. Determine the domain and range of the relation, and then determine if the relation is a function. Example 1c. It's a mapping from the numbers 10, 25, and 3 to the numbers 25 and -30. Let's start by identifying the domain, the x values, the input values. The domain of our function, our inputs, consist of these three numbers, 3, 10, and 25. The range consists of the outputs, the second coordinates, if you like. And for us, our range in this example consists of the two numbers -30 and 25. Now the question, does this relation describe a function? Is this relation a function? Well, take a look at each element in the domain. Does it go to more than one element in the range? No, 10 only maps to 25. 25 only maps to 25. 3 only maps to -30. That means that this relation is in fact a function. The relation is a function because every element in the domain is mapping to at most one element in the range. Example 1d. Determine the domain and range of the following relation, then determine if the relation is a function. Let's consider the correspondence or mapping from the letters O, E, S, R to the elements goat, sheep, fish, and deer. Now, our functions or relations don't always have to be from numbers to numbers. They can be from letters to letters, letters to objects, any way you like it. But let's take a look at this example here. We have the elements of the domain, and let's identify those first. The domain is the set of inputs or x values, the first coordinates. In this example, our inputs are simply these letters, O, E, S, and R. Our range consists of the outputs, the second coordinates, the y values if you like. In our problem, our outputs in this relation consists of the objects, the animals, goat, sheep, fish, and deer. This is our range. Now, is this relation a function? Well, it's a function if every element in the domain maps to at most one element in the range. Notice, in our domain there are actually two elements that are problem elements, E and S. E maps both to sheep and deer. S maps both to sheep and fish. That means these two elements are mapping to more than one element in the range. That means this relation is not a function. So let's state that. This is a relation, but it's not a function. And the reason it's not a function is because the elements E and S map to more than one element in the range. E maps to sheep and deer, S maps to sheep and fish. Example 1E. Determine the domain and range of the following relation. Then determine if the relation is a function. Notice in this example, our relation is expressed as an XY table of values. And recall that every XY table of values can be rewritten as a set of ordered pairs. So if you like, you don't have to, but if you like, you can rewrite this table as a set of ordered pairs or in set notation. And that would consist of the ordered pairs 0, 0, 1, 1, and 2, 4. So depending on how you like to view this, you can view it as a set or you can view it as a table. Now let's get down to business. We're looking for the domain, the range, and then deciding if this relation is a function. Let's start with our domain. The domain is the set of all the x values, the input values, the first coordinates. For our domain, in the table, it would be this set here, the x values, 0, 1, and 2. So our domain is 0, 1, and 2. The range is the set of y values, the outputs, the second coordinates. If you refer to the table, you'll see that your y values are three elements, 0, 1, and 4. So our domain is 0, 1, and 2, and our range is 0, 1, and 4. Now, is this relation a function? What do you think? Does every x value go to only one y value? It does. Notice, 0 only maps to 0. 1 only maps to 1, and 2 only maps to 4. The domain values do not get repeated. They don't map to any more numbers than the single value that they're next to. Therefore, this relation is a function because every element in the domain maps to at most one element in the range. So our relation is a function. Let's take a look at our last example now, example 1F. Example 1F. Determine the domain and range of the following relation. Then determine if the relation is a function. Again, we are looking at a table of values, an XY table if you like. You can rewrite it as a set of ordered pairs, or you can simply view it as a table. I'm going to stick with the table for now. Let's find the domain. The domain consists of all the x values, the input values. There are 4 elements in our domain. -4, -1, 1, and 4. So let's write our domain as the set -4, -1, 1, and 4. Our range is our set of outputs, our y values, the second coordinates. The outputs for this example in this table consist of the single element 0. 0 gets repeated many times, but that's the only element in our range. Now, is this relation a function? That is, does every element in the domain map to at most one element in the range? Again, how do we determine this? Well, we look at our x values to see if they repeat, to see if 4, for instance, would go to more than one element in the range. But notice 4 only goes to 0. 1 only goes to 0. -1 only goes to 0, and -4 only goes to 0. Each element in the domain maps to one element in the range. They all map to the same element, but they still only go to one element each time. That means this relation is in fact a function. So let's write it as such. This relation is a function. And the reason it's a function is because every element in the domain maps to one element in the range. This ends our examples. We'll continue looking at more relations and functions in the next topic.